Hi, today we're going to present advancing OpenScout capabilities and text recognition. So the goal for this project is to improve the situational awareness, which refers to the perception of environmental elements and events with respect to time or space. So in short, be aware of your surroundings. To address this issue, our mentor Tom has already implemented OpenScout. Uh, as you can see from here, it's a software that you can download from Google app. And when you open the software, it can detect both human faces and objects in real time. The results will be shown at the bottom, but will also be collected in the backend. So what we did in this project is to extend the capability for OpenScout project and to make it support text recognition and translation. So we have investigated several OCR engines, and we decided to choose two of them. One is Python Tesseract OCR, and the other is Microsoft OCR. So we choose those two engines because they are quite distinct to each other. Python Tesseract OCR is free, open source, and easy to implement. Even though the inference speed is fast, it has not very good accuracy. On the other side, the Microsoft OCR is not free. It costs on every request. However, even though the inference speed is not very fast, it has pretty good accuracy. So to further extend the recognition engine, we add a text engine to translate the text from other languages to English. Unfortunately, we don't get a Docker image for Microsoft translation because for somehow reason they don't approve it. So instead, we use a cloud service. So next, we will do a simple demo for our OpenScout project. So now we have a riddle here. It consists of different languages. So if we move our software close to the text has been detected is what has a bank but no money. So this is in Chinese, but it will be translated into English. What includes the bed but can't sleep? This is in Korea, and the translated is something can run but never walk. So guess what's the answer? So the answer is in Japanese. The answer is a river. So you can see with the OpenScout, we can detect the text. That's what we did for this project. And also, the data has been collected in the backend for further analysis. So the system architecture is as follows. The grid blocks are existing OpenScout projects that has been implemented by Tom. And those 4 blocks is what we did this semester. So we have a text recognition engine, which is composed of a Python Tesseract OCR and Microsoft OCR, as I have mentioned. And this is called this is an ELK component for data collection and data analysis and visualization. So actually, a few weeks ago, Yuhang, Yao, and I, we toured around the campus, and we recorded some very interesting data points. And you can see here, the red arrow is our tour route. And there are some interesting points. For example, if you can see this, we have successfully detected the College of Fine Arts with a confidence level of 90. And we also detect a professor such as Tag in front of his office with a pretty high confidence. So those data points are all collected by our text recognition on the OpenScout. So imagine if not a human, but a robot or a drone with this camera, it can detect all those useful information, and we can do visualization analysis on the back end. So next, let me pass to Yuhang to do a simple evaluation of our system.
Hi, I'm Yuhang. So now I want to introduce our system evaluation. So the first part we want to analyze is the error rate. So for the error rate, we consider we have a very huge database. We use the IM handwritten database. It contains 30,000 images. And our evaluation method is based on the character error rate and also the word error rate. So the first one is about the character error rate. So this one is composed of 3 parts. The first part is the number of substitutions, and the second part is the number of deletions, and the third part is the number of intersections. So based on the three parts, we can make it over the number of characters. After that, we can calculate the error rate of the characters. And another metric is about the word error rate. So the reason why we use the word error rate because it can actually calculate the error rate of the words, so it's more fitting the practical use. So the basic idea is also very similar to the CER. So the idea is that we use the number of word substitutions and also the word deletions. Out of that, we can calculate the word error rate. And based on the two matrices, we can start our evaluation. So we use the Microsoft OCR and also PyTestRec and compare it with the ground truth. So for this part, so the left part is the output of OCR, and the right part is the ground truth. So we can see that the Microsoft OCR is very clearly and it can clearly recognize the text and compare with the ground truth. It's nearly the same. But for PyTestRec, you can see here it's not that accurate. It's always maybe all these words are incorrect. So the PyTestRec don't have good performance. So based on the evaluation, we can actually calculate the mean error rate. So for this part, we consider median is the better evaluation. So the median CER is around 20.5%, and the WER is 36.36. So Microsoft OCR has much better performance. And for PyTestRec, it's about the median CER is about 50%, and the WER is 100%. So it's a very bad performance. So based on the study, we found that it's so for a complex handwritten text, a CER value as high as around 20%, and the WER value is as high around 40% can be considered satisfactory. So the Microsoft OCR already have a very good performance. So after the evaluation of the error rate, we start the evaluation on the computation time. So for the computation time, we mainly focus on edge and cloud latency comparison. So this part we are based on the PyTest OCR. For this work, we deployed our system into a smartphone. So we use smartphone as a client and to compare to evaluate the performance. And we also deploy it into the cloudlet and the cloud server. So the cloudlet is an edge server. It's deployed exactly in CMU. It's in the Gates center. And for the cloud server, it's a system deployed in North California. Based on the two parts, we can now compare the latency comparison with the edge and the cloud. So the first one evaluates the FPS. It's the frame per second. So you can see that the edge is the FPS is around 4.5, and the cloud FPS is 3.2. So edge is actually can deal with more frames than the cloud. And also we compare the response time. So the response time of the edge is about 200 milliseconds, and the cloud is around 300 milliseconds. So the edge has a lower response time compared with the cloud. Finally, we want to compare the computation time of the two different models, the Microsoft OCR and PyTestRec. So we use the figure for test. So this figure contains around 100 words. So it's a very huge image, and to have a better evaluation of the computation time. So we compare the computation time in different settings because Microsoft OCR actually can determine how much memory that we want to allocate to the Microsoft OCR. So we can actually manage the number of cores, number of CPU cores to evaluate, and also the number of allocated memories. So the thing that we found is that you can see this curve. So for the purple one means the PyTestRec with 2 core and 8 gigabytes memory. And for the red one, it's the Microsoft with 16 CPU cores and 33 gigabytes memory. And we found that these two parts has the same computation time. It's very small. It's around 0.6 seconds. So it's very fast computation time. So our conclusion is that Microsoft OCR is 16 CPU cores and 33 gigabytes memory has the same computation time with the PyTest Rex. And because the official recommendation system allocation of the resource is about 8 CPU cores and 24 gigabytes memory. So based on the recommendation, it's mainly based on the CPU. And for our object detection, it's mainly based on the GPU. So we use GPU to do the object detection, and we use the CPU to do the text recognition. So based on these two parts, we can allocate different memories for different tasks. And based on this part, we can have a very fast recognition of the object and also the text. So that's all. Thank you.